we're about to begin the phase in our program that we call the Lifeboat debate. And you're probably saying, I don't know what that is, and we're going to explain that to you. But before we explain it exactly, I'd like to tell you just a little bit about how this concept developed. So for many years, I've been participating in a program of the National Academy of Sciences called the Science and Entertainment Exchange, which is a group out of the National Academies, both in Washington, D.C., which is where they're headquartered, as well as Los Angeles, that seeks to interface with Hollywood and the entertainment industry to bring this science to Hollywood, as well as accurate representations of scientists, not only their science, but just what they do, how things work, what they look like, who they are, the diversity of that world. And also does work bringing Hollywood to scientists, because some people may know that not all scientists communicate as well as could possibly be communicated. So it's a really wonderful symbiotic relationship, and I've been very fortunate to be engaged over the years. And one time last year I was asked to go do something called science speed dating in Los Angeles, and I put it on my calendar, and my wife said, why are you going speed dating? And I said, don't worry. Science speed dating is just, the way we run it is there's about 7 to 10 scientists who are invited, and a whole bunch of people from Hollywood, producers, directors, writers, and they make groups, about 10 or 15 people in a group of scientists, and they go into a room, and then the scientists rotate rooms. We speed date with these groups and get about 7 minutes to tell them something interesting about science that hopefully maybe they could go home with and utilize in their work, and that someday from now, when Thor 47 comes out, there's some science in it that says something interesting. So when we were developing this program for today, and we decided together, our group, that we wanted to have a technical science day yesterday, and then this opportunity to reach out to the public in innovative ways, I thought, well, the most innovative science communicators I know are the Science and Entertainment Exchange, and Ann and Rick, who are right here. And so I called up and I said, hey, we're doing this thing, we're getting these plant scientists together, and we're going to talk about carbon drawdown. Is there anything we could do together? And they said, oh, we want to do a lifeboat debate. And I had no idea what it was, and I think I just said, sounds awesome. And so with that, I'm going to throw it to Rick and Ann from the National Academies of Sciences, who are going to walk us through this really exciting lifeboat debate.
Thank you very much, Ari. Well, the funny thing is, the part that you left out is that we had actually proposed a lifeboat debate to the Society for Neuroscience. And they said to us, basically, they said what Ari said, we have no idea what that is, but it actually scares us. And so they wouldn't do it. They thought it was a little too outside their comfort zone. So when I told Ari that, he said, neuroscientists, we are totally ready to do this. So I think that once we laid down that challenge, that the neuroscientists were too chicken to do it, and actually it was in San Diego. That really was like game on. So thank you very much for giving us the opportunity to, number one, do a lifeboat debate in this context, but to also show up the neuroscientists. So there you go. So yes, we are from the National Academy of Sciences, and for those of you who do not know, we are a private, nonprofit institution in Washington, D.C. that was created by Abraham Lincoln about 150 years ago to help the nation steer a good course towards better policy using the good evidence-based science, engineering, and health information that comes from the expertise of the people that we routinely bring together. But as Ari also referenced, sometimes communicating that work more broadly to diverse audiences is not really the sweet spot of the National Academy of Sciences. But there are some really great science communicators out there. On the other hand, some of the best science or the best communicators in the world are the people that are not that far away from here in Los Angeles, and these are amazing storytellers. And one of the things that the Academy recognized is that oftentimes the people who sit outside science, the people to whom science is not always a comfortable word, that having science communicated through stories, through characters that maybe are more comfortable for them, that's often the way that maybe makes them more comfortable with the kinds of things that we want them to know and understand. Because oftentimes you have to get people to feel something something before they are comfortable knowing something. And so bringing people together that can sort of make something feel comfortable intellectually, but also feel something that kind of generates an emotional connection is important. And there's a lot of, as I always say, Rick always says, well, this is something that you should say to people. There is a deep and significant literature base that demonstrates that this is true. And believe me, the National Academy of Sciences doesn't do anything until it investigates that deep and significant literature base. So what we are doing with this literature, with this lifeboat debate, is that, and we want to set the context for this, that there can only be one. This is kind of Highlander rules. We want you to participate in selecting the winner of this lifeboat debate. And actually, Rick, we had
this trophy made.
There is a lifeboat. Mm-hmm. It's a real lifeboat, and it will only fit one. So there can only be one. On the other hand, part of the context we want to set for this is that as we go through this, we are not trying to suggest that there is only one carbon solution to the climate crisis. We're not trying to say, and our scientists want it to be very clear, that as we ask them to take the stage and talk about making a persuasive argument on behalf of some segment of science, that's not the only way. This is not an either or, it is an and. But for the purposes of the lifeboat debate, it is very much an either or. And so you will be participating in that either or kind of conversation. So Rick, I think you should kind of explain who's going to be participating and how this works.
So earlier this morning, a group of Hollywood storytellers and scientists, botanists mostly, convened, and they each came up with, there were 6 words that we decided to craft a story around. So what you're about to hear are 6 different groups. In each group, you will have a case made for why there's a science from that word that could be useful in climate and in carbon drawdown. And then there will be a story or some kind of media piece meant to be public-facing. So this is not for the experts to see. This is just the general public to understand the idea of the science. And so you're going to hear a story, and you're going to hear something about the basic science. And at the end, you guys are going to have the opportunity to choose which one you want in your lifeboat, and that team will each get one of these marvelous trophies that say National Academy of Sciences Lifeboat Prize on them. So the first group, right, we're good? All right, so.
Are there any questions? I mean, it will become clearer as we go on, but the idea is that we are looking for the connection between the compelling science and the persuasive story, and they would be presented together. And the teams will come up here and give you both the science and the story. And you will be essentially voting on that combined science and story.
So please also keep in mind you get one vote. So don't forget the first one by the time you've heard the 6th one. I know that's easy to do. We will be voting using our cell phones, and I will show you that whole process after the 6th person goes. It'll just take a second. I promise you it's very painless and easy. It involves text messaging.
The other thing that we should probably say is that Ari is going to be the fly in the ointment here. After you've heard all of these very compelling and persuasive arguments, Ari is going to tell you what is wrong with every single one of them. Because none of these teams are going to come up here and say, so this is really awesome. Of course, you should also consider the other side of the coin. Maybe it's not so awesome. So that's Ari's job. He's going to come up and say, but, and he's going to tell you the 6 buts so that you do hear the other side of it. And if we have some time, there may be an opportunity for you to ask some questions to see if you have your own sort of perspective on this. But they're not going to get away scot-free just telling you all the rosy side of what they have to say about this. So he will be our devil's advocate. He wears it well.
So are we the oars?
You are.
You are the oars.
You are the oars.
You are the oars in the lifeboat. Okay, and before we start too, I want to thank Michael from the Botanic Garden and Ryan, our AV guy, because we threw about 1,000 things at them in the last 24 hours. And please, if anything goes wrong with the AV, totally my fault, because I changed everything on the slides about 100 times. So anyway, with that said, Samantha is the vice president of Zoic Studios, who made one of my favorite sci-fi TV shows, Battlestar Galactica, some of you may have seen. And she's going to be our first Lifeboat team leader. And are you bringing up the whole team? Okay. And their word kind of cheated. It was trees, trees, and more trees. All right.
Oh, it's timer. All right. Ready? Yep.
When you are. Good afternoon, everyone. All right. It's an honor to be here, and it's an honor to get a chance to, as a scientist, to get a chance to work with Sam. And we had some great conversations this morning, and I feel like we got lucky because our word that was given to us was trees, trees, and more trees. I think that no solution to climate change will go forward without more tree planting and trees. And we know now that since the advent of agriculture, the number of estimated trees on the planet went from 6.1 trillion to half of that in the last 10,000 years. And one thing that we started to talk about was this question, which I will pose to you all, is let's say you're typical Americans, you go through your life, you drive around, you do the things that you do, a certain amount of carbon comes out of your life into the atmosphere, out of your tailpipe, you name it, someplace like that. How many trees do you have to plant every year to offset your activity with regards to the carbon in the atmosphere? And I'm just going to hold there for you to come up with a number in your head. How many trees per year? And you have to make some assumptions. One of those would be that you have a medium-sized tree that grows to 40 years old. Let's do that. So how many of those? Go ahead and you start yelling out some numbers. Wow, that means, okay, so there was orders of magnitude different there is what I heard. Somebody said 30, right as somebody said it 1,000. So that means when you have orders of magnitude off, you're saying 2? Oh, 2,000. That means you don't know it all as a group, is what that means. So these calculations have been done, and based on those assumptions that I just gave you, the answer is somewhere around 80. 80 a year, and it has to be planted in places where trees don't currently exist. 80 trees a year. And then I would ask the next question to you, how are you doing with your 80 trees this year? How did you do last year? How do you plan to do next year? And so this was the context in which our discussion took place to start to tell a story about this. What if people were responsible for some kind of stewardship of a certain number of trees? If you and all of you, and we held each other accountable for that, for tree planting, and asked those questions of each other. How are you doing with your 100 trees this year? Because you got to plant 100 if you expect 80 to live. So with that, I will go into, is that mic live, or I'll hand this to you? You want to do? Yeah? There you go.
All right. Okay, so as Matt said, we are exploring the notion of stewardship, future generations, sacrifice, and hope in our story, and our story is entitled The Last Gardener. So it's a feature film, think Book of Eli meets Johnny Appleseed. The world that we are in is the near future in which we did not do what we needed to do to help the planet. It's dry, desolate, desperate. We are going to follow two characters, an old man, that is his name, he's about 50, and that is what his, old man, but there's a point. There's a point. And then
She means young man at 50. She means young.
well, his companion is a very young girl named Polly, so it is perhaps an affectation of a name that's kind of a joke. So we open with the man and the young girl. They're on the road. They have backpacks on. They are searching. The road is dry. It's brown. It's longing for color. And finally, in the distance, we see the smallest glimpse of green. So they come up to this point, and this is a wonderful discovery. And they find not one, but two young saplings. And for them, this is really a big find. They carefully dig up these saplings. They put them in burlap. They cradle them like children, and they begin their journey. And the girl is told, we're heading west, follow the sun. And we kind of envision this somewhere kind of from the Mississippi to Colorado, course of months. And as they journey, he teaches her what to look for. They have a very old map. Water is rare. We know to avoid what people are left. Over their journey, they'll encounter obstacles, other humans. They'll hide. At one point, there is a very severe dust storm. But around the campfire at night, he tells stories, and we learn a little bit about this man. He was a gardener. He lost someone very close to him. And he teaches the girl what he knows about plants, the world that was once green. And they journey forward. And as they're getting close to the end of their journey, kind of Colorado is in sight. They're attacked by a gang. And this old man, as she calls him, who's been crusty and grizzled and all about lessons and probably not very affectionate, at the very last moment saves the girl and loses the saplings. So they recover later. The gang that attacked them didn't really know what the saplings were. They've lost that information. He's injured very severely, but they pick up the saplings and they're broken and bent. But they finally travel and they find this valley where the water and just the environment is perfect for growth. And they plant their 2 saplings, and then the old man dies. And as he passes away, the girl buries him and says, "Goodbye, grandfather." And she picks up her rucksack and looks at the map and continues her journey. And as we pull away from her and see the 2 young saplings as they begin their journey, we go across America and see that this was not his first plant, but there are hundreds of others that have grown in maturity. This was just his last.
Yes, beautiful. Thank you.
Thanks.
Okay, so our next group was led by a TV and film director named Oz Scott, who basically, if it's a much beloved, amazing network show and it aired in the last 15 years, I feel like Oz worked on it, but recently he's a co-executive producer on Black Lightning, and he's also worked recently on Agents of S.H.I.E.L.D. and Gotham. So come on up to the stage, please. Oh, I'm sorry, and their word was also 2 words. It was root carbon.
All right. So I'm going to start the science introduction for our wonderful movie that Oz and Julie will talk about. So I think in the last 2 days we have seen that we are really at a crossroads, and everyone who has seen Joanne Corey's talk yesterday, after Ram's talk, really has understood this, that the crossroads really is. We will have a lot of issues with global warming, climate change, and at the same time, we are dealing with a much increased population, and we have to feed them. And so when we think about this, we can actually, and when you reconsider what you've heard yesterday about the power of roots to actually bring carbon into the soils, to trap carbon that has been captured by plants in the atmosphere, like trees, but also from crop plants, then we have to think about crop plant roots, because the crop plants are at the center of nutrition for the emerging population and of climate change in a sense of trying to draw down carbon into the soil. So when we do this, we can actually know that plants and land plants and all the crop plants, except for some of the kelp stuff that was mentioned yesterday, belong to the group of land plants, have roots. And actually roots have done a great job during the Earth's history already, and that's their track record, of drawing down enormous amounts of carbon when actually plants evolved root structures that solved the problem that they are not surrounded by water and nutrients anymore, but have to look for them through the substrate. And then over many hundreds or many millions and hundreds of million years, plants and the activity of roots have actually contributed to building the soils, and one of the most important constituents of soils is carbon. So plants actually have a track record of pulling down huge amounts of carbon. So how do we make them better, and how do we do this with plants that are actually at this interface of the problems that we now face of population growth, the trillions of calories that are needed, and to draw down carbon. And the idea is we make actually plant roots better in storing carbon in the soil, and do this in forms of carbon that are longer lived, that don't escape from the soil so easily. So that's the idea that we're going to think about, and that the science idea is about. Luckily, kind of related what we do at the Salk, to try to think, you know, what are things we can make better, and we can think about the root, getting more deeper roots, getting more root mass, and changing the biochemistry of roots to actually make carbon in the roots that's longer lived in the soil. And to do this, you know, we think we understand the science, and we know, you know, with enough funding money, that's solvable. But the second part that's really will be very, very crucial in the future will to actually roll out enhanced crop plants that draw down more carbon and will be as productive, or even more so, than the current crop plants. And that's actually a big leap from science that we think we have a grasp upon, or might do so with just enough resources and enough, you know, brain power in the next couple of years. But then we actually need to bring these, you know, seeds into the world by, you know, convincing the government and the industry to actually encourage farmers to plant this, and encourage companies that produce seeds to produce enough of this. And this is kind of the, you know, the setting in which our movie is situated. And I'm going to give it to Julie to tell you about our movie.
Perfect. Can everybody hear me? Yeah. Okay, so the title of our movie, which is a drama, is called The Great Seed Swap. And it's set in the future, in 2050. And at this time, very minimal climate mitigation has happened. And so across the globe, you have the planet is suffering in terms of droughts, floods, fires, etc. Species are starting to die. There's a lot of population refugees. Is really at a very critical point. And at this point, also another thing that happens that really puts the scientists in a bad situation, and that is that the new government comes into power and no longer supports any plant-based carbon solutions, and actually bans, stops all funding, actually bans all use of genetic plant-based technologies to be deployed. And so, in addition to that, the new government has convinced the public that the dire straits of the planet in climate change is due to technology, creating a really negative sentiment towards the implementation of science solutions. But meanwhile, by the time we've gotten to 2050, a group of scientists led by Wolfgang Roots, who has really is a zealot and has like a very passionate about root systems, which, you know, it's not so far from the truth. He has already been working with a team of plant geneticists and has engineered a series of different crop plants and generated seed stocks of these plants that should be able to store more carbon in their root systems. So they really are facing a dilemma that they have this technology that they think really can have a positive impact on the globe, but they're facing even more extreme roadblocks in terms of implementation. And so Wolfgang rounds up a set of his colleagues, including Julie Subrin and Scott Monsanto, who come into play later in the story. And what they decide to do is that they're going to skip these lengthy government approval steps and the generation of ag partnerships, and they decide to break into the ag companies and swap out their carbon sequestering seed stocks for the normal stocks. So this goes off without as planned, and they swap the seeds. And then farms around the planet, farmers around the planet plant the seeds, and it begins to work. The climate is becoming more stabilized. CO2 levels are dropping. But then there comes a hitch in the plot, which will be taken over
So
by
we're
Oz.
5 years. We're 5 years into the future. Our Wolfgang route has been proven correct. The government, of course, is taking credit because they feel that we keeping our hands off, nature will take care of itself. That we did not need the sciences, but a problem has arisen. 5% of the crops are dying from a new disease, and 1 death has been reported from the possibility from these infected plants. What starts to happen is an investigation starts to go forward. Because of the death, because of the zealots on the opposite side who are accusing the ag companies of doing something, Julie confronts Wolfgang Root. Wolfgang wants to stay with it. He does not want to, he's still in his zealot mode. And she confides in her boyfriend because of this what's his name, Scott? Monsanto. She confides to him, worried, concerned, having second thoughts, and tells him about the seed swap. He, of course, being the loyal Monsanto, that's enough to be said, he goes and he turns them in. They go to trial, the companies there's lawsuits coming up, everybody's starting to turn against them, and they go to trial with, and Julie, who had been very much on his side, turned state's evidence. And
Okay. So essentially, my character feels remorse that perhaps there was something having to do with the seeds, even though it wasn't proven. So it turns in state's evidence. They have an investigation. Through the course of the trial, it comes out that there was nothing wrong with the seeds. So there was no foundation for the death, but nonetheless, now the trial is happening, and the culprits of the seed swap end up convicted for bypassing all the regulatory rules and swapping out the seeds. And
here's where we come to. We have quote unquote happy ending where the people start to see that technology and what's going on can happen. But of course, being my cynical self, they go to jail. There's a major question as to what should we do, what should happen. You still have the zealots still rousing up the people. But what Wolfgang Root has done is he's thrown a big question into people, and Julie finds that she has to continue his work, and that'll be the sequel.
So our next word is rhizosphere, and the storyteller is Brian Davidson from Skydance Entertainment. Before that, he was at Disney Animation, where we worked with him on Moana and Big Hero 6 and Zootopia.
Thank you, folks. Thank you, Rick. We're big supporters of the exchange, so glad to be here. So here to talk about the science are Jason and Lila.
To start?
Yes,
oh my God! But I'm busy trying to help my boreal tree who is in need of nitrogen.
Feed it.
Yeah, I know. And I'm going to need to talk to a fungus about some nitrogen, I'm afraid. So.
Oh goodness.
Oh,
well,
dear.
this rhizosphere. What is it?
It's basically a marketplace for roots.
Okay.
Yeah. It's a hidden marketplace under the ground, and that's how roots exchange nutrients and other stuff with other organisms.
Really?
And, I'm really sorry. I have to go because this grass glass needs some phosphorus. It's going to have to talk to some phosphate solubilizing bacteria, I'm afraid. So I'm
This is really dominating your life, isn't it? Okay. No, yeah. Well, go ahead, please.
Should we talk about the game? Yeah. Oh, great. Hi. Can I check my blood pressure? Let's see how's it going. Okay. I want to talk to you about Marketplace Earth. This is, as you've seen, a highly addictive social media application and game for all ages. Are you still playing? Put it away. We're up here. It's highly playable. It's a version of either Farmville or Tamagotchi. How do you play? You start with a square meter of Earth in a forest environment, and that is your ecosystem to manage. And the goal is to sequester as much carbon as you can and ensure that that is a healthy and viable ecosystem. Carbon is, for every bit of carbon that you have, and there's already a bit in the ecosystem, that is your currency, that is the points that you have to spend. How do you spend those points? Jason, you want to talk about that?
Well, you can spend those points on different things that enrich your particular ecosystem. So the idea is to build up as much carbon as you can in that plot of land that you've been given. So you can use it to, say, enrich with fungi that are allowing your plants to draw more nutrients, more elements from the soil, which allow them to grow bigger. You can even spend it to communicate with other people. So you can spend some of your carbon that allows you to open up your world to somebody else's world. It's connective, it's interactive, and in doing so, you can enrich your own land. So essentially, you're trying to pull as much carbon as you can out of the atmosphere, and then you get to spend that carbon on things that allow you to pull even more carbon out.
Great. In this rhizosphere, there's a lot of choices you have to make. This area around the root system of a living organism. And it's a strategy game, and you have to make, you're confronted with obstacles and problems and have to make specific choices. Do you want to talk about what some of those choices are?
Well, somebody walked across this soil and made the soil really compact, and now I'm having to sort of get my root tips to grow through that soil. It's a nuisance. I'm a bit pissed off about it, actually. And furthermore, there's been a drought, and I didn't grow my roots deep enough to reach the water in the deeper layers of the soil. So I'm a bit SOL at the moment. That was a bad choice.
I can save you. I'll transfer some carbon credits, maybe to yours.
This is a big part of the game, is that it's interactive. And it's
See, we belong to the same mycorrhizal fungal network, and so he's going to, I'm hoping that he's going to share something with me.
How are you communicating? How are you connecting with each other?
I just had a family of moles go through my blocks. I can't do anything for you.
But my seedlings that are connected to my network, they're gonna wither if you don't help.
Yeah, it's one of the problems. So no, the fungi are actually able to communicate with one another. So we're communicating through other organisms. Kind of a fun concept.
Yeah. So it's a fascinating game, as you can see, to play by yourself. But more importantly, you're connecting with other people as you grow, as you try to make your own ecosystem healthy, and you're communicating these underground networks. It's also it is a marketplace, and like human marketplaces, there are boom and bust cycles. What are some of those?
Well, like I said, I did not grow my roots deep enough, and then it was unusually dry, and I wasn't expecting that. That's not fair. But something. I mean, there is a cold season as well, so I'm ready to sort of go a bit dormant for that one. So that's okay. And I have an ecosystem in California as well, and that one is used to dry periods, but within reason. Because I have some fungi that are helping me get some water out of the deeper sort of cracks in the bedrock, which is.
So as we're playing, we're making some good choices. We're helping each other out, and our ecosystems are flourishing. We're pulling more and more carbon out of the air, which is exciting. And there are rewards. What are some of those rewards?
Well, the best thing for me about playing this game is not only is it highly addictive, and not only am I learning a bit about the rhizosphere, which I couldn't even pronounce about 5 minutes ago, but I actually have achieved enough carbon in my virtual world that allows me to apply that to the real world. So upon reaching that level, somebody has now planted a tree, an actual tree, and so there is some real benefit to playing and participating in this game.
Yeah, a big part of this game is about actual actions that happen in the real world. So upon reaching certain levels, due to a sponsor that has not been named yet, but coming soon.
Who's in this audience? Yeah.
We'll find you. Actual trees will be planted as a result of you achieving certain levels. The other outcome, I think, is that we talk about individual actions, but also how those can translate into collective actions. So I think that's a big way to mobilize people and get people to think collectively as well. What else should we tell people about Rhizosphere? Anything else?
I think that's good.
Coming soon to your iPhone. Marketplace Earth.
I bet you didn't see that social media game coming, did you? Thought it was all going to be movies. So our next word was parination, and our storyteller for this group is Diana Williams, who is currently the Executive Vice President of Content at Madison Wells Media. She does all sorts of multi-platform activations. Before that, she was in the story group at Lucasfilm, where she worked on a franchise you may have heard of called Star Wars.
Hello, I'm Lee DeHaan, the scientist part of this group. It's been a lot of fun. I had no idea what I was getting myself into when I said I would come in at 7:30 this morning, but it was really cool. So I just want to talk to you about this word perennial or perination. What does that really mean? And often people really don't have a sense of that, except if you look around here, and if you're into gardening or botany, you know that most of these plants live for many years. That's all it means to be perennial, a plant that lives for 3 years or more. And that's actually most of the plants on the planet. So it's almost like saying plants. And the weird ones are the annuals. So there's a smaller number of plants that only live for 1 year. I should say a smaller number of species, because there's lots of individual plants on the planet that do that. So these plants are, in the natural environment, are really adapted to going into when there's a disturbance. So my part of the world in Kansas, a buffalo wallow, what's going to come in there after the buffalo killed all the grass? There's going to be some annual weeds that'll pop up there. After a volcano or a severe event that wipes out most of the perennial plants, there's a period of succession that happens. So some plants come in first. Those are often short-lived annual plants. And then eventually the soil builds up, they get outcompeted, and then we have forests made of perennial plants. We have prairies made of perennial plants. Most of our ecosystems are dominated by these perennials. And what we've discovered is that we look at what humans did was we went with annuals when it came to what we eat. So what we're doing is having to essentially create a disturbed environment every time we want to grow our crop. We have to make it sort of like a volcano just exploded. All living material is dead, and we come in and put these seeds, and they do great because there's just tons of resources and nutrients there. What they don't do well is using them efficiently. So annuals take abundant resources after a big disturbance event and make a lot of seed because they're going to die. They got to make a lot of seed. And so that was really attractive to us humans. We came along and started using those. And before we knew it, we were addicted to these annual plants, and our whole culture depends upon them. And we have a hard time living off of perennial plants. Tree crops would be great, fruits, nuts. But incorporating perennials back into our agricultural landscapes is a key way to get carbon from the atmosphere down back into the soil, because these perennial plants that live a long time tend to have very deep roots, very extensive roots, 5 to 10 times as much root biomass, often 2 to 3 times deeper, putting that soil down in the locker, so to speak. And that carbon that moves down those huge roots then drives the soil ecosystem and provides healthy soil and allows plant health to improve over time. So we get kind of this virtuous cycle. We end up with, by putting more carbon into the ground, we not only improve the soil carbon and take it out of the atmosphere where it's causing trouble, but we make plant growth better. So plants start to grow better and better and more resilient to that stresses that come through climate change driven by atmospheric carbon. Right? I'll pass it off for the story.
And resilience is a big word because part of, I think, what we're all trying to do is get messages across, but across in a way that is also entertaining. So it's sugar-covered carrots, which already has a lot of sugar in it. But my point is, so what we've come up with is as a board game. What we want to do is be able to bring a family around an entertainment, around an idea, and around a way in which to communicate ideas back and forth. So our board game is called Resilience, and it's resilience of people, resilience of the earth, of soil, and of the atmosphere. So it's a great word to just put on top of a box that'll come off of the shelves. And so part of the game is it's about strategy and it's with a point system. So those of us have played Monopoly and Settlers of Catan, all these types of games in which you have to come together and figure out how to keep something going. So ours is about keeping civilization healthy, food production, good soil, and atmosphere below a certain carbon number. It's also a way for people to learn really what carbon is, because those of us that are not in science, we just hear carbon, 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 carbon bad. And then what blew my mind, and according to Sam, I'm old with my age, that to realize how important carbon is to the soil. And when part of the education that we get is that leaves take the carbon out of the air, and then we get oxygen and things, and then it just stops there. We have to understand the whole cycle. And that is what this game does. It provides a way to understand the cycle of what perennials do and how important they are. But if you are to have a civilization to start with only perennials, well, everybody's going to die because there's no food. So what is the balance? And how do you balance out these four types of things between your food, your soil, your atmosphere, and your people? And that's what this game does. It is all about strategy. So throughout the course of the game, the player experiences events as well as warning signs, which will cause the player to reevaluate their strategy with the cards that they have that have a point system. So some of these events could be, name all your plagues in the Bible, plus Monsanto. So those are events that will cause you to rethink how you're looking at your cards and how many perennials you planted, or how did you plant wheat or corn. And then what was your food production? You can also have like a population boom, so therefore you have a lot of people. Oh, you only planted perennials, do you have food to feed them? So these are the types of things that help you to understand the context of the world around you and understand your place within it. The age group for this would be 10 plus due to the context of understanding resource strategy. And it's a way to also have the conversation so that we are bringing up a younger generation to understand the context of the world that they are in and not feel so afraid by these words that are being thrown at them. Carbon, climate change, these are all big words. They need to just kind of distill them down in a way that is fun and entertaining. And by understanding these cycles, they can understand their place within them, and they can avoid being scared or paralyzed or confused. We want to bring them along with us as we are trying to solve a problem, not blame people for something that happened in the past. So the bonus from this type of game will be made from bamboo, which is a perennial, so they'll learn about that. The potential for a very younger kids version, which will teach them which plants are perennials, what are annuals, what those mean. There's also a companion app, which is a quicker game, which uses more of a Dungeons and Dragons type of master, kind of like a gin rummy, so you quickly have to figure out what your points are, and events come at you faster. And there's also a call to action mechanism, so you can learn more about what you can do within your own world. And you may be thinking, like, why a board game? It's like the overall goal is to engage minds, young and old, via entertainment, so that concepts, conflicts, and challenges to their future become a bit more understandable, which allows it to become more relatable. And then hopefully they feel a part of the hunt for solution as opposed to pointing fingers for blame. That's the only way that we're going to be able to move forward. And the thing that struck me in working with Lee is that through everything that he's been doing, there still is that faith that we will be able to figure this out. And I think that is the most important thing. But you can't have faith without action. And so this game will allow you to understand the action, and also understand that the context of how difficult choices are, that every choice has a consequence, and that there is no black and white, and not everything is so easy. And that's what this game setup does do, is that, yes, great, you fed your people, but for how long, at what sacrifice by not having perennials. So unlike the competitive setup of this lifeboat, remember, we are number 4, that resilience cannot be zero-sum. There is no longevity without, of food without tending to our soil. So this is the promotion of cognitive thought, not finding fault. And that, there are ways that we can tackle all these problems, and the great thing about all the different sciences up here is that they're showing different ways in which to tackle problems. And the great thing about entertainment is that we can find ways in which to bring these different ideas out to different types of public, so hopefully we all come together for a solve. Thank you.
In a cruel twist of fate, they're actually going to be number 3 if you want to vote for them. So, number 3, we're the 4th to go. Our next group is Novel Ecosystems, which is also 2 words. Chitra Sampath is a TV writer who currently has Truth Be Told. She's a co-executive producer on that show on Apple TV. And before that, she wrote for Sleepy Hollow, among many other shows.
Okay, all right. Just a heads up, we changed our word to permaculture. So if you like what permaculture says, vote for Novel Ecosystems, I think. Do you guys want to talk about science?
Yeah, so we're thinking about novel ecosystems that are coming in the future, and things are going to be different than the past. And one of the ecosystems that we want to explore is permaculture ecosystems, which are permanently cultured agricultural ecosystems that are building soil, and also in the marine permaculture environment. So maybe I'll go through a few basic points about land-based permaculture, and Brian could say a bit about, briefly again, on aquatic, and then we'll jump into the story that we have about it. So there's many layers in a permaculture system, and the idea is to really regenerate and build up soil fertility. You've got crops and cover crops, perennial crops, agroforestry, and trees in the right mix, integrated across the landscape. And below ground, you're absorbing and retaining water and improving water holding capacity, and also enhancing nutrient cycles, phosphate and nitrogen cycles, compost and biochar and rocks, and a whole complete cycle that those nutrients from the plants are then feeding the next generation of plants. And the carbon is accumulating and building underground, and you can also extract and harvest your agricultural resources. So that's the concept of permaculture and regenerating landscapes.
Everyone take in a big breath. Most of the oxygen you just breathed came from the ocean. Paul Revere once said, "Once if by land, twice if by sea." We have to take care of our primary production in seas and soils in order to ensure that we can keep nature on track and keep our civilization stable on this planet. I'm going to quote Winston Churchill when he said, "You can count on the Americans to do the right thing after they've tried everything else." And with that, I will turn it over to our entertainment.
So our story, the way that we're going to bring the message of permaculture to the masses and the average Joes who don't have the scientific background you do, is through a short film called Family Farm. And it's a sentimental family story about a man named Plaid. He is a farmer. He's lived on his family farm his whole life, and he works the farm alongside of his aging father. The farm hasn't been doing so well lately. It's not as productive as it was when he was a kid, and a lot of their neighbors have sold their farmland. A lot of Plaid's friends have moved, and Plaid knows he can't do that because the farm is too important to his father, so he stays there. But then his father passes away. And Plaid thinks, okay, this is my opportunity to move on to what he sees as the future. And his sister Lucy comes home and he says, Lucy, it's time to sell the farm. And Lucy has brought her boyfriend, Wolf, and she looks at Plaid and she says, no, not today, Plaid. So he thinks, okay, she needs a little bit of time. So he waits, and a few days later, he goes to Lucy, and he says, Lucy, we have to sell the farm. And again, she says, no, not today, Plaid. So Plaid's on the farm.
And he's missing his planting cycles. Normally they should be tilling the field by now and putting the fertilizer on, but things are going by, and so the farm is continuing to degrade, and he's waiting for his sister to just sign the papers so they can move on.
But again, same message, not today, Plaid.
And Lucy's boyfriend, Woof, which stands for will work on farm for food, but maybe not everybody knows that. He's wandering around the edges of the farm having a look, and he leaves the gate open in the back, and the beavers come in quietly, and they re-engineer some of these erosion gullies, and then a big storm comes in that night, and it floods the farm, but it doesn't erode down the gully the way it always had. It spills up over and floods the whole farm, and Plaid's going, what's going on? You know, things are getting worse faster, and so he's waiting for his sister.
But again, not today, Plaid.
So they're waiting, and Wolf's continuing to wander around the farm, and there's some trucks going by, and they're loaded up with all kind of organic waste, and they say, well, can we get rid of these on your farm? And Wolf says, sure, just dump it over here. That's no problem. It happens to be right where the beaver dam was, and another rain comes, and this time it floods over that compost dump and spreads the nutrients all over the farm, and this is just terrible for Plaid. He has no idea what this is. Just never do we farm. This is going wrong. So he turns to his sister.
Not today.
So another week goes by, and Wolf has some few seeds in his pocket, a bunch of weed seeds that happen to be legumes that fix nitrogen. He spreads those around, and the next time it rains, there's nutrients and water spreading across, and these weeds come up, and so there's now a cover crop establishing on the ground, and Plaid's just about to lose it, and he can't take it anymore, and he goes to his sister, come on, it's time to sow.
Not today.
So this is like the last straw for Plaid, and the old stumps of the trees that he's worked his whole life with his father to get rid of, they start to shoot up these new shoots, and now the weeds are taking over, and the trees are starting to regenerate, and a wolf comes around and prunes them a little bit, and they start to establish into tree rows. And so he goes back to his sister.
He goes back to his sister and he asks again, and she says, no, not today, Plaid. But then he looks around his farm and he realizes this is the best his farm has looked in years. He's got this thriving farm and he never saw it coming. And then finally his sister comes to him and says,
Wolf went off to the beach one day, grabbed some seaweed off the beach and dragged it onto the farm. And it got spread around by all those beavers. And then Plaid goes back to his sister.
And Wolf's ready to go now. His work's done. And so his sister says.
now she says, okay, let's do it. We can sell the farm. But Plaid looks around and then looks at his sister and says, not today. And then the screen goes white, and we see words cross it, and it says 10 years later. And we see Plaid, and he's standing on his thriving farm, and a drone goes up in the air, and then you see that all the farms around his farm are thriving. All of his friends and neighbors have come back. He's taught them what he knows, and permaculture has saved this community.
All right, so our last group had the word, again, 2 words, blue carbon. And they were, our storyteller through this group is Kieran Fitzgerald, who has a long and storied career. He made many documentaries. He's probably best known as the writer of the Edward Snowden movie that starred Joseph Gordon-Levitt, which means he met Edward Snowden, which means that he's probably on every government watch list, and we're likely all persons of interest at this point.
So we started off by saying, okay, what is blue carbon? And I was like, Kieran, what is blue carbon? And he's like, well, it's like the person from Avatar, right? So, I mean, we have to really tell you what blue carbon is, and it's really appropriate for our location. So blue carbon is the carbon that is, the carbon dioxide that is removed via plants and macroalgae from the ocean and the coastline. And although it's debatable exactly how much carbon is actually pulled out in these ecosystems, we know that it's a lot. And we also know that these ecosystems are in great danger. We've lost a lot of plants in the coastline, and for those of you that spend any time in the ocean here, we've lost a lot of macroalgae or kelp. So I'm going to pass it on to Abby.
Thank you. So the three sort of most common coastal blue carbon ecosystems we talk about are marsh plants, mangrove forests, seagrass beds, and kelp and other macroalgal beds. You might wonder why we don't also talk about phytoplankton, because there's so much of it, with the open ocean being the largest habitat on the planet, and it does a lot of photosynthesis. The reason for that is it turns out that carbon is kind of like El Chapo Guzman. It is really good at escaping from containment, and the catching it isn't as hard as the keeping it caught. And while there is a lot of phytoplankton doing a lot of photosynthesis, normally what happens to that phytoplankton is it either dies and then rots and the carbon escapes, or else it's eaten by something which respires it. So even though phytoplankton does a lot of photosynthesizing, it's not a great blue carbon sink. What makes seagrass beds and marshes and mangrove forests so good as carbon sinks is twofold different characteristics. A seagrass, their tissue is very rot resistant, so it doesn't break down easily. And also the sediment they're growing in is very low in oxygen, which means almost anything that gets buried there won't rot. So they've sort of got a twofold containment device. Macroalgae or seaweed is a bit more complicated because it's less rot resistant and doesn't usually get buried where it's actively growing. In order for macroalgae to be a good carbon sink, it needs to grow and then die and be transported into deeper water where, even if it does rot, that carbon won't make it back to the surface for a while, on the order of hundreds to thousands of years. And figuring out what percentage of the macroalgae that grows actually does that has proven to be tricky business. And at this point, I would also like to do a quick quiz of the audience. Can anyone tell me the difference between seagrass and macroalgae? Yes. What? Exactly. So seagrass, its ancestors were land plants. It has roots, it has leaves, it has flowers. Seaweed is algae. Its ancestors never lived on land. It reproduces with spores and usually feels kind of slimy. Another thing I want to mention about the advantage of using blue carbon as a means, or using these ecosystems as a way of sequestering blue carbon, is they also have other side benefits. For instance, they're habitat for a lot of the fishery species. So for humans who depend on seafood for their primary protein source, and I think that's about 1 billion people total, that helps ensure their food security. Also, these areas are habitat for a lot of species that we might want to protect even if we don't want to eat, like shorebirds and things like that. Also, they help protect the coast against storm surge, and they help protect offshore coral or oyster reefs against sediment pollution from land. Where using blue carbon gets a bit tricky is restoring these ecosystems
can be a bit complicated. Usually, if a seagrass bed or a kelp forest has died, it's not because anyone came in and killed it on purpose, like has typically happened with forests. So just trying to replant it won't work unless you've also dealt with the factor it killed it, whether that's excessive runoff and sediment or nutrient pollution, or perhaps removal of a keystone species that was needed to keep it alive. And that makes things tricky. Marshes and mangroves would theoretically be easier to restore because they're land-based, and a lot of the loss of those has been deliberate destruction. Unfortunately, there's a lot of coastal development in the way of doing that, and in our story, we talk about one rather extreme way of dealing with that problem.
Thank you. I'm going to dumb things down considerably and tell you an idea for a movie that we're calling Aaron Brockovich meets Fight Club. So this is a bit zany, political, romantic satire with eco-terrorist undercurrents. And we're calling it La Reconquista, the reconquest. And I'll explain that title a bit more as we go. So we have two main characters who are going to fall deeply in love, and they are young, brilliant scientists who meet at Scripps. One is from Mexico. Her name is Salma Seagrass.
Will not be played by me.
Possibly played by Salma Hayek. And her paramour is Johnny Apocalypse, possibly played by Johnny Knoxville. And they fall in love with each other and also with the idea of saving the world through their shared love of blue carbon initiatives. And they soon realize, upon returning to Mexico, Salma wants to do work in her home country. Johnny will follow her anywhere. And they soon realize that their ideas of how to go about this diverge considerably. Salma wants to start planting mangroves, kelp, seagrass. And when she becomes frustrated that too much of the human population on the coast, particularly in Cancun, where our story is set, is getting in the way of the efficiency of the carbon drawdown, her boyfriend takes matters into his own hands and says, well, I can do something about that. Let's get to saving the world a little faster. Let's get rid of all of these gringos and spring breakers. I'll just simply blow up the hotels. So he plants a bunch of dynamite and promptly detonates the hotels. But he's a little hasty. And he's not a very good terrorist, or rather not a very good humanitarian, because a couple of people die. And she looks at her boyfriend in a new light and says, this man is crazy. And I guess I should have known. His name is Johnny Apocalypse. What am I going to do? I have to leave him. This is unethical. Johnny sinks into a deep depression and starts drinking tequila. Subsequently, however, she realizes that from the accident of Johnny's mayhem is born a new opportunity, because the hotels, the ruins of these hotels, have created perfect conditions on the coast of Cancun for her to grow her seagrass, kelp, and mangrove. And so she realizes in astonishment that actually this might work. In the meantime, a new threat is bearing down on her in the form of El Chapo Guzman, who was mentioned earlier, because he had a financial stake in these hotels, and he is angry that they've been blown up. And so he comes after the woman he thinks is the perpetrator, and Johnny Apocalypse has to come out of his tequila stupor and do something about it and save his girlfriend, which is really the only way he can redeem himself at this point after being a very naughty man. And so he saves his girlfriend, but in the process, he himself perishes. He sacrifices his life to save Salma Seagrass. And Salma is devastated, but realizes she now has even more of an obligation to live out and carry on, let's say, the better angels of Johnny Apocalypse's mission on Earth. And so she decides she's going to go around the coastlines of the world and blow up hotels, making sure that everyone is out. But there's also a part of her that needs revenge. So she thinks, I've been using this metaphor of El Chapo Guzman in teaching science. Well, I'll just take El Chapo himself and I'll trap him inside one of these hotels before I blow it up. And then El Chapo will literally become carbon under the ocean, contributing to the salvation of the human species. And that is our movie.
So first, thank you to all of our storytellers and scientists who participated in our crazy game. Now, at this point, you may think that there's a front runner. You may feel like you know who the best choice is for you to vote for. But now's our moment where Ari Novi from the Botanic Garden comes in and tells you pitch by pitch why each of these ideas is terrible. And when I initially described this to Oz Scott, this whole process, he said, "Oh, Ari's the studio executive." So there's your piece. There's your peek behind the Hollywood curtain.
Thank you. So I'm now going to uncharacteristically tell you why plants suck and can't solve any problems. But I just say before that, all these scientists and storytellers did not really know what they were doing when they met at 8 o'clock this morning, and this is the result, and that's really fantastic. All right, that's the last nice thing I'm going to say. Where am I going to start? With the whale of the plant world? That's a solution. The whale of the plant world. Blue carbon. All right, I'll go backwards. So we want to plant seagrass, mangroves, and kelp, and save the world. There used to be a ocean of kelp, literally about 2 kilometers wide from Santa Barbara, all the way down to the Mexican border, and it's gone, and none of you miss it. None of you knew it was there. None of you care. So I just don't see that that's really a big solution, guys. I'm sorry. Permaculture. All right, so we have something where we have to permanently cultivate while simultaneously neglecting it and letting beavers run over it and do things that we didn't ask them to do. And that is a solution. I feel like the majority of my arguments are long, confused looks. It's funny, permaculture is an interesting technology. I once was this is true, I was in the Philippines and somebody was showing me permaculture and I said, "What is permaculture?" Because I really didn't know. And they told me it's being able to reach all the plants from one place in the garden. Because you can sit in the garden permanently and not hurt your back. So I know that wasn't your argument, but there's a lot of confusion about what permaculture seems to be out there. I don't know, I just don't really see that by neglecting things, we're really going to get further forward, and it kind of sounds like that's what you guys want to do. You want to sit around and go, maybe we shouldn't do anything and let nature take over, and all of a sudden that leads to a very high level of productivity. I don't know. Just not seeing it. Sorry. All right. On to perennialization or perennation, longer-lived plants. Longer-lived plants. So we have plants that don't live long enough, so we need to make them live longer. So the idea here is that we're going to give up what we, for over 10,000 years, has been our survival. The fact that we have annual plants that can grow and produce incredibly large percentage of biomass from themselves. Some of those plants produce 60% or more of what they produce we eat. And so now you want to go to a system where maybe 5% of what the plant makes we can eat, under the sort of dubious notion that it's going to get some fungi to help it out, and then that's going to create long-term stability. Okay. Rhizospheres. The marketplace under the ground where microbes talk and trade. I would like to take some mushrooms and go there. I don't know that the marketplace on Wall Street or Chicago or any of those places cares. I don't know. I think what the hardest thing for me to understand about these things is that there's just tiny little things, and then you're asking us to accept that these tiny little things have these, really outsized impacts when you scale them up at a global level. I don't know. I don't know if I can buy that. We seem to have cut down a whole lot of trees. I think we heard from Peter Raven earlier that Europe managed to cut down pretty much all of its trees by the 1800s, and it seems like they were just coming into peak power about that point, and they're doing just fine now. Root carbon. Longer-lived roots, deeper roots, longer roots. I mean, I think, we're compensating for something. Tiny, tiny hands, maybe? I don't know. And we're going to enhance the crop plants. We're going to take all the corn and all the soybean and all the rice and all the wheat, and we're going to make it have longer-lived roots, deeper roots, and longer roots. I thought that, the Green Revolution was built on shorter plants and a little bit less biomass, but more of that biomass turning into the stuff that we eat. And I'm pretty sure that somebody won a Nobel Peace Prize for saving 1 billion lives that way, so I'm not sure why we're going in the other direction. All right, last one. Trees, trees, and more trees. All right, it's like the Lorax kind of gone on steroids. I don't know, it's interesting to make that argument in Encinitas, California. Encinitas is, in Spanish means little oak trees. And it was named Encinitas because people got here and there were no trees. And yet they were literally no trees. There are no large trees in the landscape naturally in this part of the world, except maybe by some of the waterways when there's not so many waterways. And yet they described it as a paradise and everybody came here and now you want to bring trees. I don't understand. Honestly, I think you guys, all you biologists, should just get out of the way and let the physicists and the engineers do their jobs and put mirrors into orbit to reflect off some of the sunlight, and we can just do whatever the hell we want to do. And, simulate a volcanic explosion, right? That's another one. Easy, easy stuff. I don't know, guys. I'm just not seeing it, I'm just not seeing it. But I realize what I've said has been a little devastating and maybe, difficult, and you might have a response. And so I think what we'd like to do is invite all of the groups up here, and there is enough time for the audience to ask some questions and see if you guys can't resurrect your ideas from my devastating takedowns. So come on up. And while they're getting up there, who would like to ask a question of one of our groups?
I just have to say it's not accidental. The beavers were intentionally coaxed in, and this boyfriend Wolf, which will work on farm for food, he knows what he was doing. So.
So my question is, what can we as humans do to enhance the rhizosphere other than playing a game on our phones?
Yeah, I'm not dropping. Not before I've said anything. So one thing you can do is look at planting and maintaining diverse systems. So typically rhizospheres, healthy rhizospheres are well adapted, mutualistic assemblages of species that benefit one another in different ways. So they're able to utilize the resources, from the atmosphere and from below ground in ways that maximize productivity, that allow us to get the sorts of services, the ecosystem services that we are after. And of course, one of those tremendously important services is carbon sequestration, but there are others as well. Better water quality, better air quality. The food we eat is an ecosystem service provided for us. So, it depends on what system you're looking at. Are you looking at a garden system, an agricultural system, a natural system? All the things that we do to enhance the quality of our soils, improve the rhizosphere.
It's probably also a good idea if you're going to plant things that are actually adapted to the ecosystems where you are, because those are the ones that are going to be able to work with the existing soil organisms and which will be able to be more resilient to the local climate and conditions.
Another thing that's not maybe directly related to gardening or farming practices is, over the last 2 days, we have heard a lot about the importance of the rhizosphere, of roots and carbon and soils. And so I think everyone here could just spread the word that, roots are actually, an ally, and root systems are our allies in trapping carbon down. And this is important for people to know, because most people don't know there's not a lot of funding available and not a lot of, knowledge in the public about this. And so I think, apart from, if you have a farm or a garden, make sure your roots are all right. Spread the word and encourage stakeholders to actually do something for the development of practices or genetic material or strains that actually have advanced root systems and sequester more carbon for longer.
So we have a question back here.
What is your favorite tree?
We'll send that one to the trees group, no?
My favorite tree is a kelp tree, and it lives in the ocean right next to us.
Encinitas is named after encina, which is actually the Spanish word for the coast live oak, a very common native tree that's around here, Ari, that was here when people showed up.
Tiny and shrubby.
Except in all the areas where you have water and all the waterways, they were massive
All those
and beautiful.
massive areas of water around here.
Well, that being said, the coast live oak is a native oak around here, and we could plant a lot more of it, and we could do a lot better with restoring the oak woodlands that are in this area in Southern California.
Oh, I'm losing.
There's your rebuttal.
Fine. Emphasis on the butt.
There's room for scrub oaks and live oaks. My question is about this rhizobium in the soils and all that. Not everything in the soil is good. What about, you guys aren't mentioning any diseases? What about, the nematodes and verticillium fusarium? It's all part of the stuff under the ground, and not everything under. Just because it's under the ground doesn't mean it's a plus, plus, plus.
Well, I mean, surely, actually, this is a little bit outside my area of expertise, but I think that those sorts of problems become much bigger problems if you have a monoculture. So perhaps diversity in your planting is something that could be considered to avoid diseases completely devastating a crop.
Yeah, also, if I might. So yeah, clearly not everything under the ground is good. I mean, like I would say roots of plants we want are good, but of course there are a lot of pathogenic bacteria, fungi, and issues. And again, this is something that one can assume that there are some traits that might be beneficial for carbon accumulation in terms of relating to healthy, more extended root systems might be able to deal with if you think about breeding approaches and so on. So, I think the bottom line is that if we want to think about practices or different germplasm, different seeds with improved root characteristics, disease control or the resistance to disease is a very important consideration.
So identifying a collection of species that can coexist together sustainably is a key design tenet of permaculture. The objective is to create enough diversity within an ecosystem to have resilience. And in fact, you can quantify the resilience of many ecosystems by the diversity of the species that are present. And so by building stronger and stronger ecosystems, we actually develop permacultures that are sustainable naturally and also can be sustainably harvested by humans. And that's how we define permaculture in many ways, is that evolution of sets of species that can coexist together even with sustainable harvesting.
Can I say something? I'm not a scientist. I haven't got a clue what y'all do. But what was interesting was in our pitch, we took into account diseases. We took into account of, you know, things do happen. There are consequences to decisions. But one of the things that really hit me, and when I asked, and I know science can be easy, but implementing it with the politics, with the funding, with all those other things that stand in the way of what you guys are doing is something that sometimes is the bigger problem than the science itself. And with any solution, there will become problems.
And along with that, when we were talking about the board game, the idea that you can present all these different types of issues, the fact that you brought up soil, which I grew up on a farm, and we had because we had a disease in the soil, it killed one of our crops, that these are issues that you can bring up and then talk about the context and how it works against something else and how it works for something else. And so I think bringing up all these issues is so important so people understand that there are no easy solutions if we don't talk them all out and see all the different angles.
Can I just say, I did also forget to mention that there are meant to be freeloaders in here. So in other words, that there are things that parasitize other plants, like Striga is an important one in Africa. If it gets into your fields, it'll attach itself to the roots of all your plants, and it can almost be a write-off. So those sorts of things also I should have mentioned them, and I forgot.
Okay. I have two questions. Do I have to pick one? Okay. Well, okay. So one of the things that seems to be missing, there seems to remain here in all of these stories the idea that there's nature over there and us, and maybe our stories are a little bit parallel, but I want to challenge that idea and say that the human story is a natural story, and our bodies are walking ecosystems. And how can that fundamental idea that there's no there, that it's all us, I could talk a lot more about that, but I'll just throw that out there as an idea. How could these stories be adapted to tell that fundamental shared identity of humans as natural systems, and the parts of the natural systems?
At least for our story, although it had to be cut for the sake of brevity, part of Salma Seagrass's motivation for wanting to replant seagrass and mangroves was that she was going to be originally from a fishing village that's economy crashed because the hotel moved in, and by destroying the mangroves and the seagrass, there were no more fish and the fishermen had no more income, and she wanted to be able to bring back the fish habitat so her people could have a sustainable living.
So The Biggest Little Farm is a great film up in Santa Barbara that was inspiration for our family farm short film. And I think the idea that cultivators in permacultures are living in coexistence with their ecosystems is really essential to the idea. And by observing well and seeing what's working and not working, we can use permaculture design philosophy to coexist with nature.
Yes, the games. Thanks. So I wasn't clear in listening to the games. Are these games where people are competing against each other to win? Or are these games where people are cooperating with each other to get a higher score?
At least in our game, the idea was the higher score, to maximize the amount of carbon that you are storing in your particular plot, as well as to maximize the carbon in other plots too. So that was part of the communication. There is actually an advantage to players who cooperate in our game rather than those who compete.
In our game, we have it both ways. So the players are each their own civilization, and they're trying to figure out how to grow their civilization through all parts. The other way would be that each player takes one player's food, one player's soil, and so each time, so they're trying to make one civilization grow up. So we have it both ways. So by having it that the player is the civilization, so you're competing against other civilizations. What we're trying to affect is the idea of like understanding how difficult decisions can be made when you're looking at all the parts together. And then by having it be cooperative is understanding how everybody works together to have a growth of civilization. It's a great question.
Okay, I have a coastal live oak in my front yard, and it's very healthy because I don't water it. But anyway, I have a question for the roots people. So I'm a plant scientist. I've made many GMOs and converted cells and things like that. And I end up fielding a lot of questions from the general population on several topics. But one of them is that monoculture question. So what could you add to your story, to your movie, that would really get people to feel the understanding of how it's not going to be the end of the world? If you begin with monoculture, where would that story lead to? How can you tell them you are going to have diversity and you're not just going to be stuck with these things that could be killed by disease?
Okay. I think that's a very good question, but it's also a question very hard to answer because the trillions of calories that we need as a human civilization, it's hard to imagine how we can actually move away from a highly efficient agricultural system. What we have to do is to make it definitely more sustainable. But, I mean, maybe we can, afford to go to Whole Foods or, buy in the organics aisle. But especially, poorer, basically less privileged, groups or countries will have a problem with this, right? I mean, and food is so cheap because it is very efficiently to produce. So it is a very important question to increase sustainability, I mean, clearly, and I think replenishing the soils with more carbon is one aspect that, will be crucial in terms of soil health aspects and being more, applying less fertilizer, less susceptibility to drought and floods, because by adding more carbon, you increase basically the water holding capacity of the soils and nutrient availability. So that's one piece of the puzzle. But it's hard to imagine if we think about an ever-growing population in our agricultural systems, how you could switch, on a very large scale to actually maintain the amount of calories we need, at least in the very foreseeable future. But I would be happy if, anyone had a real good solution.
I think I want to say that it usually takes us a good week to create these pitches, and we've created them since 8 o'clock this morning, in 15 minutes here, 30 minutes here. But I think the one thing that you all can even talk about, you all can consider, is exactly that. These stories, these games can grow from what we've, I think we're being very simplistic in some ways. We're trying to get through some ways. We're trying to get by the network executives in some ways, because they only think in simplistic terms anyway. But I think you guys adding, it would be great to hear how you would add to some of our stories to make them bigger, more interesting than what, well, ours was real good, so I don't know.
In the biggest little farm, many of the early monocultures failed, and they had to go to polyculture in order to get that resilience. And so you either do that with chemicals, but we know that better life through chemistry is pretty bankrupt. And, or you can get it through living soils, and you can get it through polycultures of diversity above the soil and diversity below the soil. So that's the thesis for a lot of the work on The Biggest Little Farm and related permaculture efforts.
Yeah, at the Land Institute, we kind of advocate two major things that we learn from nature, perenniality and diversity. And diversity at all scales. We can use that principle from varietal diversity within varieties, mixing them in one field all the way to multiple species on the landscape to multiple species in one field. So there's so many different ways to deploy diversity, and agro-ecosystem design is about doing that in a really smart way for the farmer and for whatever services you want to see out of that system.
I have a question. In the farm movie, you mentioned using seaweed to improve the soil. How's that possible?
Well, in a nutshell, the seaweeds provide a biostimulant function that's been essential for California wineries for decades. And so it increases the yield of grapes, and that's been really profound. I think that can be applied to row crops, and then we're looking at double-digit yield increases for biostimulants from row crops to vegetables. So it is really diverse. And anyway, it's something to look at and see more market penetration in the future.
Okay, we're going to have one last question, and then we'll get towards voting.
Thank you. I am from Mexico, so I love the last story. It's almost my life. I just need to boom or make explode some resorts and have a handsome boyfriend, but it's almost my life. But for the writers, I have a huge question. I am a biologist and I have a scientific background. And I always have the doubt of what is the feeling that I have to put in any comment that I said? I have to give some hopeful and romantic message, or I have to say something more realistic, dramatic, and maybe sad about what is happening right now. What do you suggest me? What do you suggest? Thanks.
I'm happy to make a biography about your life anytime. I think that a variety of approaches is ultimately the best thing for us. But if you look at the most successful documentaries about climate change, Inconvenient Truth keeps coming up, right? There have been a lot of other documentaries about climate change, some of them financed with a lot more money. That one, and I think the lesson from the success of Inconvenient Truth is not just that it came out when it did, at a moment when a wide swath of the public wasn't yet educated about climate change. It's that it was a personal story, and anytime you are able to tell a personal story, as opposed to hitting people with a political message or with a specific emotion, you're trying to get them to feel hopeful, you're trying to get them to feel sad, you're trying to get them to feel depressed. I think those approaches will always be less powerful than simply telling the story of one person's life. Because Al Gore's personal story is what makes that movie. Regardless of what you think about him or his work, that's why it was a success. And so I think that that's probably the biggest takeaway for me in telling stories. And I've talked to Al Gore about this during, at a festival where they premiered the sequel. He was just as surprised as anyone else that the movie took off, because he's not a very interesting speaker. By his own admission, he's pretty boring, right? So it's asking yourself, why did that work, is, I think, a good clue.
Can I say also, hello? In the narrative, in telling a narrative story, what's fascinating for me is listening to all these scientists. It's listening to because they get me going. But one of the things I've always said, what I say is, people, our audiences don't care about boy meets girl, boy loses girl, boy gets girl back again. They're interested about who are those people and how does what you do affect those people so that boy meets the girl. What affected them for boy loses the girl, and we want to root for somebody. And I think what you said it is a personal story in whatever you do, because To just talk science to me, I'm going to be like, you know, like my science teacher back in high school. You know, they lost me. But when I can root for somebody and I'm invested in them, I'm invested in who they are, what they want, I can root for them, I can sit there and cheer for them, I can get depressed with them, I can see where they lose things, and I can see how I can help. And it all comes down to you and me, and that's the way you tell a story.
Yeah, to add to that, I didn't know what the rhizosphere was until I came down on the train last night and Googled it. But sitting with Lila and Jason, hearing their passion for that space was so infectious, and it made me look at the world in a new way. So I would say passion is infectious, and don't underestimate the power of your own convictions. If you can communicate that passion and excitement for a subject, it spreads.
So I'm going to...
The power of story, anyone can do it. If any of you have heard of the deficit model in science communication, you will understand that information does not matter nearly as much as people caring. And it is these storytellers and it is the stories that make people care. And if, as I say, if the National Academy of Sciences can do this and understand, it is within the power of every single person in this room to take their science and make it mean something.
Because the National Academy of Sciences is the most boring. All right, so please pardon me, I'm just going to sneak up here. So now you get to vote. Now, the system will only let you vote once. Can we, Ryan, can you help me out with the, yeah, here we go. Oh, yeah, you guys can go ahead off if you want. So we're going to pull up, this is a test to show you that the system's working. Hopefully, this will work. So we're going to bring up the live page of the phone one. Is it working? We can always do the analog show of hands, so don't worry. It's a good backup. It's a good backup. Is it?
Yeah, exactly.
Yeah.
That works so well.
It's not going to work out? Okay. Should we, are you not up on the site? Is that the issue? It's just not going up to the screen?
So,
all right,
we don't
what
have
should we
to
do?
test.
So,
Could we just go live to voting? Could we put the PowerPoint screen up and have people?
okay, can you put the website on the final voting thing and then put the still of the PowerPoint? Oh, is that live? Okay, great. Okay, we got it then. So our first polling question is, do I know how to use my cell phone? So please take out your cell phone, and you're going to send a text message to the number 37607. That's 37607. And the text message you're going to send is the exchange 462. That's the exchange 462. I don't know if it's case sensitive. I don't think it is. So you can text, it should text you back, I think, immediately and say you're in the system. And then you can text the number 1 or the number, there you go, someone got it. So you could text either the number 1 or the number 2. It may be case sensitive. I don't think it. Okay, great. All right, now this is looking more promising. Okay, good. So, how many people have not gotten this to work from their phone's perspective? Because I don't have the actual numbers of how many people have voted, I don't think. Yeah, it's moving around. Is there anybody who hasn't gotten this? Okay. You just put in a 1 or a 2 once it tells you, once you've texted the exchange 462 to 37607, once you've done that step, you text either 1 or 2. Okay. To have it text back to you takes a second. Oh yeah, this is delayed. You won't actually, when you send your text, it'll take a second for it to register. There's always one. There's always one. Or two. It's not working on yours? 467. Oh, 462, sorry, 462. It should get you back. Okay, all right. Did you do one or two?
Found a phone up in the room we were in this morning. Did anybody see the phone?
Yeah, that's weird. Oh, okay, yes, that's because you voted, right? Okay, so now you voted for this poll. Most of you voted for this poll. That means that you can't vote for this one again. However, you can vote for, could you do the static slide for the, can you, move the poll over to the next one, to the PowerPoint, but then also put up the static slide. So we don't want to influence your voting based on who's already winning. So we've taken a picture of the slide, and we're going to put that up now. That's live now. So now remember, wait, is that the old one? That's the old one.
We just need to go right back to the PowerPoint slide, the PowerPoint deck we were on.
Yeah. Sorry, this is not an AV issue. This is a us changing things all over the place issue. So sorry for that. It should be the 3 slide that you had on earlier.
Did you close out the deck?
All right, just we'll let them. That's one. That's the old one again. All right, why don't you just put up the website? It's okay. We will influence you by what the rest of your audience mates are doing. It's okay. Okay, so you just be full screen in the next one. Yeah, there you go. All right, thanks for working with me on that, Ryan. Okay, so remember, novel ecosystems is permaculture. My apologies for that. That was my mistake.
So this is when you vote.
You get 1 vote.
If any of our teams want to try to influence the audience, now's your time to be handing out the $20 bills.
No, I think it just goes up. Yeah, this is the trophy. Oh wow, look at this, it's tied. It's pretty exciting. All right, it looks like Rhizosphere and Blue Carbon. Wow, that is extremely close.
Keep voting.
All right, does everybody feel like they voted at this point? General consensus? Not yet? Okay. Oh, wow. Whoa.
Shout out your numbers.
Wow. This really does feel like the Iowa caucuses.
I know. I'm surprised there's not more like competition from the teams yelling out there.
All right, is there anyone who feels their vote has not been tabulated in this count at this point? I think. All right, now, I just want all the teams to know you're all winners in my heart.
But as I said, it's Highlander rules. This boat is small.
It looks like this boat is going to the Rhizosphere. So thank you very much, guys. Can we have someone from Team Rhizosphere up here to accept the award here? Come on up. There we go. All right, come on in.
We have to speak? Thank you. Do you guys want to talk?
Thank you very much.
There she is.
Well, I'm surprised. I expected Blue Carbon to win, frankly, but anyway,
I
thank
have
you.
to lug this back with you on the plane to England.
I will, yeah, that's fine. I can cope.
This is quite a trophy.
It
I
is.
mean,
Yeah,
so
it
we
is.
usually give plaques. They're just, now our plaques seem very sad, but Rick likes nothing better than an awesome plaque, and he felt really excited about doing something special for this. So this is probably the most amazing thing we have ever done, just so you know. So.
Do you have any champagne we can drink out of this?
A round of applause for our winners. And can we get a round of applause for all of our scientists and Hollywood creative folks for such an amazing presentation of knowledge?